In this section of the course, we're going to take a look at program flow control and logical expressions. This really is the meat of ABAP programming. This is where it all happens. How you structure your program using logical expressions determine the complete flow of your program and in what sequence actions are taken. So first of all, let's have a look at control structures. Now, when we create a program, we break a program up into multiple tasks and subtasks. We control how and when these sections of our program are executed using logical expressions and conditional loops, often referred to as control structures. So let's get straight down to the ABAP code and have a look at how we define these control structures to make it easier to understand what I'm talking about. First of all, let's create a brand new program where we can test out some of the logic we will build. So I'm going to take a copy of the Z OpenSQL1 program that we used in the previous module. With the program name in the text box, just click the copy button and we'll give our program a brand new name. Let's call this Logic 1. Z Logic 1. And we'll just choose copy, local object, and our program has been duplicated. So let's go into change mode. And we'll tidy the program up a little bit. And what we will do is just keep this first section and make some space. So when we talk about control structures, we are talking about blocks of code that allow us to make a decision, and based on that decision we can have a number of different outcomes. Let's take a look at the if statement to explain the basic logic of control structures. Now, the if statement is probably the most common control structure that is found in just about every programming language there is. The syntax of the if statement does vary from language to language, but its use is pretty much universal. So if we have a look at the piece of code that we created in the last module, we have this if statement. If a logical expression, do something. And then we have an addition saying else, do something else. And then the end of the if statement. So if we were to just talk about it in pseudocode, we would just say if a logical expression we would then do something, and then we would end our if statement. So you can see if starts the expression and the end if is the end of the expression. So this allows us to see that a control structure has a start with the if statement here, and it terminates with our end if statement. Both of our statements belong together, and every control structure we create will always have a start and an end. Now, when we break our program up into smaller tasks, we will break these tasks up that would allow us to branch off in the middle and do some other smaller task, which in turn could have its own if statements, its own control structures, to do even smaller tasks. When we have defined our control structure, what we put between the start and the end determines what tasks are going to be performed as subtasks. We branch off and do something else, or we repeat a whole bunch of tasks in between our control structure in what we call loops. Things are going to get a lot more interesting from now on. We will be using control structures like the if statement to determine the flow of our program, to execute different subtasks or branches of our program, and to perform loops. So to begin with, I'm going to comment out all this code for now. And I'm going to write some code here and see if you can determine what's going to happen. And to do this, let's make use of the pattern tool. So I'm going to click the pattern button, Ctrl F6, which brings up the insert statement dialog box. And all I'm going to do is go down to the bottom where it says other pattern and just put in if. Now what this has done, it's brought back the structure of an if statement that we can follow as a guide, so that for those that are new to ABAP, you will get the syntax right and you won't have to worry too much about the actual placement of the full stops and so on. So we have our if statement. Now I'm going to do this. I'm going to create a data statement that's going to hold an employee's surname. So I'm just going to create a field called surname, a type character. I'll give it a length of 15 and pretty it up. We're going to set our surname to a value, and then we'll use the if statement So there you can see I've written some logic. Now can you work out what that's going to do? It's pretty easy. Let's execute the program and see what it says. Oops. Silly me, been using the wrong quotes. And again. Oh, I do apologise. So there you go, you've won a car. So yeah, this is a very simple if statement, just saying if the surname is equal to Smith, and of course it is because we've set the surname to Smith already, it performs a branch of our program. So let's extend this program to include the else if statement. And it's quite simple. Let's say now if Smith equals Brown, this time you've won a boat. Now as you can imagine, our surname equals Smith, so you're going to win a car every time. But let's change it to Brown. And now you can see the outcome is you've won a boat. So what we've done here is the first if statement was not true. Therefore, this branch of the program was not executed. So it went down to the next branch in the statement, which is the else if. Else if surname is Brown, which it is, then it will write this branch of the if statement. And we can keep on with the else if. We can, repeat it any number of times. The only problem is I may run out of prizes. So this one is a plane. How fortunate for being named Mr. Jones. Oh, didn't notice I had the extra full stop there. And lastly, let's change this one to Andrews. And what does Mr. Andrews win? He's very fortunate. He wins a house. So as you can see, we can keep going on with this structure, and depending on what is true, different branches of this logic block will be executed. Jones, you've won a plane. Andrews, you've won a house. Now the last part is the else statement. And the else comes in when it's the last piece of your if block. So we could say, if your name isn't any of these, what are you going to win? Unlucky. You go home empty-handed. So by introducing these different else if statements and the else statements, there is always going to be an outcome that is performed depending on the value of surname. We have taken care of every single possibility. If it's Smith, we're going to do this. If it's Brown, we're going to win a boat. If it's Jones, a plane, Andrews, a house, anything else, we're going to do this block of code. So the if statement is very powerful, and it is the key logic statement used in just about every program going to determine the flow of your program. We have a whole set of ABAP operators that we can use with our logic statements. So as we have seen with the if statement, we've been using the equals. We also can use the not equal to, which is the less than and greater than sign together, the less than, the greater than, less than and equal to, and the greater and equal to. Now ABAP, because of its roots, also has some other ways of writing these. And these are the EQ for equals, NE for not equals, and you can work the rest out. Less than, greater than, less than or equal to, and greater than or equal to. More and more, you tend not to see these being used too much, and I suggest you don't use them because everyone's now familiar with the standard way of writing these operators. And like I mentioned in the previous video, we're not limited just to these. We can link logical expressions together using the OR operator, the AND operator, and the NOT operator. We will come on to these in the examples that follow. So we can link our logical expressions together just like this. Let's copy the if statement for surname. And instead of a full stop here, we can then use one of the linking operators. In our case, and we'll say forename equals John. So there you can see we've used the AND operator to link two logical expressions together in this one if statement. So the rest of the code that make up the statement would be like this. Very simple one. The right statement represents our statement block of code that we would want to execute, and then we close the if statement with the end if command. So that's using AND. We can also say if surname equals Smith or forename equals John, execute the code. Now, let's have a look at nested ifs. Now, as you can see with our else if, we are nesting our logic just one level deep. We're saying if this, do this, else this, do this. Now with a nested if, we can go down to a more detailed level. Let's have a look at an example. So first of all, we have if surname equals Smith, we're going to write something out. Well, at this point, with the nested if, we can say if forename equals John. Else we can say, ooh, you're so close. And then we end this if block with this line of code. So let's pretty it up and go through it. So we have our first if statement, if surname equals Smith. Then instead of writing out you've won a car, we're nesting another if statement saying if forename equals John. Now for completeness, just noticed I haven't created forename, so let's stick that in there. Okay, so if forename equals John, you've won a car. Else, oh, you are so close. So we are checking two logical expressions. To win a car, you've got to have a name of Smith, and you've got to have a forename of John. And then for each if statement, we close it with a corresponding end if. Now you are not limited just to nesting, down to 2 levels. You can go on to your heart's content. You could do a 3rd level. And if we pretty it up, it should indent it for us. So you could have something else. So if the surname is Smith, forename is John, and then, another field here. Location, UK. I know we haven't defined it as a field, but you get the idea. We can keep embedding logic like this until it meets all the criteria for your program. And you don't always have to nest if statements one after another, just like in this case. We could have a bunch of statements here, a bunch of statements here, some more statements, some more statements at this point. So going back to when we started this exercise, we're looking at, we define our control structure, we then execute some code, then we close our control structure. So the code that we execute can be anything at all. Writing, reading from database tables, more logical statements, such as the embedded if. You can introduce loops, call function modules, anything you can think of. And that's really it for the if statement. That's the structure. You have the if, you have the else if, you have the else, and then the end if to close off the block. And you can nest if statements and other logic statements as deep as you wish. So the if statement analyzes a logical expression. And like any other programming language, we are not just limited to an equal. We can use any logical expression. We can use the equal, not equal, less than, greater than, the or, the and, the not, and so on. So let's have a look at some of those and see how they are written in ABAP. I want you to keep in mind that when you create logical expressions, and especially linking logical expressions together, it's always best to make sure your code is as readable as possible. And the reason why I say this is because if you start producing code that's like this, well, even though it will work, we're linking lots of expressions together. Oh boy, it's so difficult to read. So try and limit the number of logical expressions you do link together. Structure your code a little bit differently where you might use multiple single logical expressions, one after another. Or if you don't want to do that, at least structure your code so it is easier on the eye. For example, we can line things up like this. And so on. I won't keep going, but you get the idea. It's a lot easier to read something like that than the code that we had before. Now this brings us on to the next statement I want us to go through, and that is the case statement. The case statement does a similar job to the if statement, but it has the flexibility to structure our code so it's a lot more readable, but at the same time is limited to one logical expression. Let's take a look at the case statement so it's easier to understand. So we will start a new block of code. Let's have a separator here. And we will begin the case statement with the word case, and we will use the surname and forename fields that we've used previously. So I will write the code first, have a look at the structure of the statement, and then we'll compare it to see how it differs from the if statement. So we have case surname, full stop. Then we include the word when. And this is where we put our values. Let's copy this write statement to save me typing. I'm sure I've got a Jones a little further up. I certainly do. Mr. Jones wins a plane. We'll introduce a new Mr. Green. And Mr. Green, well, he wins the boat. And last but not least, we have our closing when, and we say when others. Then lastly, we end the case statement with end case. So let's pretty it up, get the indenting correct. So now let's go through the case statement again. So the first thing we do is we use the word case and we say case field name. So in our case it's case surname, and we are checking the contents of surname, and we are going to perform an action depending on its value. So we are saying when the surname equals Smith, you've won a car. When it's Jones, you've won a plane. When it's Green, you've won a boat. And anything else with when others, you don't win anything, unlucky. And then we close the case statement. Now personally, I think the case statement is much easier to read than lots of nested and linked if statements. And when we look at the differences with the case statement compared to the if statement, well, just as I mentioned, the case statement can only check one field, whereas the if statement, by using linked expressions, we can check multiple fields. Just like here, we're checking the surname and forename field. So this is a limitation with the case statement, it just checks one field. But I still like it. There's not much more to explain about the case statements, but before we move on, I will just mention, just like with the if statement, case statements can be nested. So with our example, where we have when Smith, we could write out some text to the screen and then we could introduce another case statement. And we can choose to have a case statement on another field, include the when, just like so. Oops, I do apologise. That's better. So there you can see a nested case statement within the original case statement. In this video, we are going to discuss iteration statements, otherwise known as looping statements. We use iteration statements to execute a block of ABAP code multiple times. So to start off with, I'm going to generate a new program by copying the one we used in the previous exercise, and then I'll strip it down so we can start fresh. There are various ways to loop through blocks of code in your ABAP program, and we can separate these types of loops into those that have conditions attached to them and those that do not. Now you've already been using a loop in the form of the select statement, and the select statement allows us to iterate through a record set. So let's revisit the select statement. And we've been using it in the form of select star, which means select every field from the table. And in our case, it will be Z employees. We would then have some ABAP that we would loop through. In this case, let's just do a simple write statement. And by doing this, Z employees, it would output the entire record onto the screen. And then all we need to say is end select. So as you can see, this is a very simple loop. Select every field from the table, write the record to the screen. Let's correct it. And then we get to the end select, which means we have finished writing our block of code, go back to the start until there are no more records left in the record set. So let's do a syntax check. Oops, we do have an error. Oh, my apologies. I missed the table statement at the top. Pretty it up. There we go. So let's give this program a quick run and you can see it in action. As you can see, it's looped through the entire table and output the contents to the screen. A very simple loop. Now, I did mention our iteration statements come in two forms, those with conditions and those without. Well, this is a select statement, a loop, without a condition on it. But we can add a condition very simply. In this case, let's extend the first line of the select statement to say where surname equals Smith. So now when the select statement executes, it will only select records where the surname is Smith and output them to the screen. Let's do a quick check, make sure the code is correct. Activate it and then give it a run. And nothing was output. Let's have a look at our table. Oh, look at that. We've got rid of all our Smith records. Let's use another surname. Let's choose, we have Jones, our first one, or Mills in the middle. Let's choose Mills instead. Everything is good. And there we go. It's output the one record where the surname is equal to Mills. So you can see it's quite easy to add logic into your select statement to limit the number of records you're going to iterate through. Let's now take a look at the do loop. A do loop is very simple. We start with defining the do loop. We then execute a statement block. And then we end the do loop. So in our case, we would change our statement block to our write statement. Instead of Z employees, we will just output the word hello. See the pretty printer? Oops, look at that, making silly mistakes. Here we go. And as you can see, it's very simple. But one thing you might notice is that there's nothing telling this loop statement when to stop. Let's see what happens when we execute this code. As long as I put the proper full stop in place. So now we're executing the program, but see how it's stuck? This is because this do loop is processing thousands and thousands of times per second and outputting the word hello to the screen. So we're stuck in a loop, and that's not good for anyone. So we need to come back out and amend our code. So what do you think we need to do here? Well, we need to add some mechanism to this do loop to tell it when to stop processing the block of code in between the do and end do statements. And that's where we introduce the times addition. And the times addition would go straight after your do. So we would say 15 times, for example. And now when we test it, you can see the word hello is written out 15 times. Tell you what, let's stick it on a new line so it's easier to see. There we go. So the do statement is useful for repeating a number of tasks a specific number of times, but you must remember to always include the number and the times addition. Otherwise, you could end up in an endless loop, just as we did in the first example. So now I want to rewrite this do statement. Let's, instead of writing out, let's have some processing. Let's have a equals 0. Oops, wrong line. Do apologize. Let's define okay, so we define a as an integer. we set its value to 0, and then what we will do inside the loop is a calculation. A equals A plus 1. So this is just going to be a very simple counter. And what I want this to demonstrate is the do loop actually uses an internal counter to control how many times the loop is executed. You can check the SY index system variable to see how many times your loop has been processed. So let's do that. First of all, let's make sure we write out our own counter, and then we can compare it against the system counter. Everything looks good. I'll stick a breakpoint on the do, and then let's execute it. Okay, so now we're into the code. Let's step through it. I'm going to use the F5, single step. I'm going to double click on A so we can monitor that variable value. And what you need to have a look at as well when we execute the first one is SY index. And as you can see, that has a value of 1 as well. This is a system variable. You don't have to declare it. You just need to be aware of it. So let's execute the loop again. As you can see, as soon as we step into the loop, the SY index increases by 1 to indicate we are in the second iteration of this loop. Then our own counter gets executed and we write it out to the screen. And so on. And it will keep executing until it gets to 15. And I'll just zoom along. And there's our output. And once again, I should have stuck it on its own line. And there we go, all 15. As with many other statements, do loops can be nested. And if you do nest them, each do loop will have its own SY index created and monitored by the system. But do be aware that when you start nesting do loops and other types of loops, you need to consider how much work you're going to make the system do. So let's get straight in and have a look at an example of how we nest another do loop inside this one. So first of all, well, I'll leave that breakpoint on, and then let's call this outer loop so we can monitor it properly. And then let's do our do loop statement inside. So we'll do, let's say, 10 times. And we'll do a similar type of statement. We will write out the value of B on its own line. I've remembered it this time. We'll call this inner loop. Let's just get it all in line. And don't forget, we need to declare our variable. Now, because we have a do loop inside our original do loop, let's initialize our variable b at this point. Because if we did it up here, its value would not be reset every time we got to the inner do loop. So by doing it here, we can do this second do loop 10 times, and then when the first do loop comes round to its second iteration, it gets reset to 0, and then it will count to 10 again in the second loop. And finally, let's just do one more little thing, just to count the total number of loops that we are processing. We'll have a variable called C, also of type I, and at the very end let's do this. We'll write out the value of C, but so it adds up correctly, what we need to do at the end of each second do loop is let C equal the value of B. So once it does 10 times, the value of B will be transferred to C. No, actually we need to do C plus B. So it gets added up every time. And then at the very end, we can do C plus A. So this should be a good counter for us to count up how many times the system loops through both loops. So the first loop is 15 times, and then in each loop it loops 10 more times. So we should, if my math's correct, have around about 150 loops. That's quite a lot of code being executed. Now, obviously we're using an SAP system and it's going to process this instantaneously. But you can imagine if you were processing through, let's say, 10,000 records at this level, and then you had 50,000 records at this second level, then 10,000 times 50,000, I can't do the maths, but it would equal a lot of iterations, and it could take quite a long time. So just be wary of nested loops. Anyway, let's get on and test our code. Our breakpoint is set here at line 22, so let's just execute it. And we'll bring up the values of A, give it a double click. Tell you what, change that to B, and we'll put C there. Now we will also bring up SY index at this point, and we can see that as a value of 0. And while we're processing through this code, keep an eye on SY index and notice how the value changes as we go from the outer loop to the inner loop. So let's get straight on and step through the code. So our first loop is going to be done 15 times. As we step into it, SY index equals 1. We will increment the value of A, write out our first statement, and we can see that B gets initialized. And now we're going to step into the second loop. SY index is 1 again, but because it's the first time we're going into this second loop, we don't actually see any change in the value, but SY index is pointing at the second loop now. It's monitoring this SY index value. As we step through, you'll see it change. So B is incremented by 1, we write out the statement, and now we're into the second iteration of the second loop, and we can see SY index is equal to. And as we step through, it should do it 10 times. So now we're in our 10th iteration of this inner loop. Goes back up, registers it's been done 10 times, jumps straight down to the end do statement, then processes the calculation of C. And then continues on in this first iteration of the outer loop. And we can see the SY, wrong one, sorry, and we can see the SY index has been changed back to 1. So we'll carry on. And now we're in the second loop of our outer do statement. And as we jump into our inner loop, SY index should be reset to represent the value of the inner loop. And so it is. So to save my fingers, all this key pressing, I'm just going to place a breakpoint on this line of code. Then I can press the F8 key, which is the same as this one, to zoom through. So we can see B, which is our inner loop, has been processed 10 times again. And C gets incremented to 20. And so on. I'll just press F8. I'll keep pressing it. And we can see our outer loop is going to be processed 15 times. Here we go. End do to the bottom. And then C gets incremented with the value of A. And we write out the final value of C. So we can see our outer loop, then the inner loop values, outer loop again, inner loop, and so on. As we scroll down to the bottom, we finally get the total number of loops that have been performed in our code. Now it might have been a little bit better if I was just to maybe increase the number of positions from the left-hand margin of the inner loop print. I'll double click the breakpoint to get rid of it and then zoom through the code. There we go. That's easier to read. And there we go, so that's nesting do loops. We're now going to take a look at another looping statement, and this one is the while loop. Now this differs from the do loop in that the while loop checks for a condition that we have defined within the while loop before it executes any code. All the statements between the while and end while statement will be repeated as long as the condition is met. As soon as the condition is untrue, the loop will terminate. Just as we did with the do loop, we also monitor the SY index field to see how many times the loop is executed. So let's get straight in and have a look at the code. Let's introduce a few blank lines. And what I'm going to do is just comment this out because we don't want all this do loop output onto the screen. And then we'll take a look at the syntax for the while. So it's quite straightforward. We have while, then we have a statement, which is our condition statement. So let's do that, condition statement. Then we have a block of code that we would execute. And then we end our end while loop with end while. Pretty straightforward. Looks quite similar to the do statement. So let's turn this into proper code. So we have our while statement and we would change this conditional statement to something proper. So we can say while A is not equal to 15. Let's copy this. Well, it's not equal to 15. We can output the value of A. Now at the moment, A will always be less than 15 because we are initializing A a little higher up in the code. So what we need to do after we write out the value of A, to ensure we don't end up in an endless loop, we need to increment the value of A. So we'll just do the simple A equals A plus 1. Tidy our code up. Execute it. And we can step through the code. So we will monitor the value of A and also SY index. And as we step through the while loop, it will check the condition, and as we can see, the value of A is 0. So we write out the statement to the screen. Then A gets incremented and the loop continues. And notice our SY index is incrementing just as it did when we took a look at the do statement. So I'll just keep my finger on the button here to step through until we get close to 15, which we're right at right now. So we'll do it end while, checks the condition, skips the statement block, and goes to the end of the loop. And then outputs everything to the screen. Now because A started with a value of 0, that was the first cycle. So the maximum value A reached when it was output on the screen was 14. So what we could have done, just to get 15, is just swap these statements around, just like that. So A gets incremented first. I'll press F8. There we go. So there we have the 15. It looks a little bit easier on the eye. So that's it, a very simple while loop. Just as we did with do loops, we can also nest while loops. The process is exactly the same. So we're not going to spend too long on this, but I will do the code so it gives you an example, and then we will just zoom straight through the code. So I generate some space, and we'll follow the example we did in the do loop. So we will use the A, the B, and the C variables. So the first thing we need to do is initialize our B variable, and then we'll create another while loop. While B not equal to 10, we can write out our statement, and obviously we need to use the copy and paste. And then it's important at this point to make sure we increment B. So just as we did with A, we'll increment B right here. So B equals B plus 1. If we didn't do that, we'd end up with a continuous loop. It would never end and we would be stuck. So we have that. We'll bring that line back up. Then we'll increment C. So C equals C plus B once that inner loop ends. And we can have our last end while and then write out our final line. There we go. So I just have a final check. We're incrementing A, resetting B, incrementing B. That will do it until it reaches the 10th iteration. We write out B, increment C. Oh, and there's one more. I need to increment C here with the value of A. There we go. Have a code check, then activate it, and then we'll run straight through. I don't think I've got a breakpoint set. No. There we go. So we have the same type of result as we did with the nested do loop. We can see our outer loop, then the cycle of 10 inner loop statements, outer, and then inner, and so on, until we get to the bottom, where we can see a total of 165 iterations. Let's move on. Up to now, we have gone through our loop statements and let the condition inside the loop statement determine when the loop will finish. ABAP contains termination statements that allow you to terminate a loop prematurely, and there are two categories of termination statements: those that apply to the loop and those that apply to the entire processing block in which the loop occurs. So first of all, let's have a look at how we terminate the processing of a loop. And the first statement we're going to discuss is the continue statement. Now this allows us to terminate a loop pass unconditionally. And you'll see when we take a look at the syntax that there are no conditions added to the statement itself. When I first started ABAP, I thought the continue statement seemed a little bit odd. Why would you want to use the word continue to terminate a loop? It just seemed a bit backwards to me. But maybe that's just me. The continue statement actually means do not process any more statements in this loop. Just immediately end the processing of all the statements in the loop right here and jump to the start of the loop again. So if we include the continue statement inside our loop, the remaining statements will not be executed. As soon as the continue statement is hit, processing jumps right to the top of the loop again and starts another loop run, as long as the conditions set by the start of your loop statement are still met. So let's have a look at the structure of the continue statement and go through a quick example so you can see exactly what I'm talking about. I will use the do loop for this example. So let's get rid of this while and bring back our do loops. And we don't need an inner do loop for this example. Let's get rid of B. Okay, then what we're going to do is introduce an if statement. So let's say if sy index, which should be the same as the variable a that we are setting as a separate counter ourselves. So we're saying if sy index equals 2, then we will say continue. And that's all there is to it, just that one word, continue. Then we will end our if statement. So what this is going to do is start this loop. It thinks it's going to execute it 15 times. Then as soon as we're in this second loop, we will hit the continue statement and processing should jump straight back to the top of the loop. Which means we are not going to write out this outer loop cycles text with a value of a on the second loop pass. So let's run through. I will put the debugger on. Here we go. So we'll step through. Let's have a look at the value of a and the value of sy index. So if sy index is 2, which it's not, it's going to output the text to the screen. And we'll have a quick look. There you go, there's the output. So we'll step through again to the second time. Now sy index has been set to 2, so this statement should be true this time. So we get to the continue statement, and you can see execution jumps straight to the top of the loop again. And I'll continue processing, and we're on the third iteration. So as soon as we hit the continue statement, the rest of the code was not executed. processing jumps straight out of the loop back to the top. So now I will just zoom along to the end. There's our output, and we can see we have 1, 3. So we have that missing 2. The next statement we'll have a look at to terminate the processing of a block is the check statement. The check statement allows us to terminate a loop pass, just like the continue statement does, but it allows us to check certain conditions. We can use some sort of logic. So when we define our check statement and define the logic, if the condition is not true, any remaining statements in our current statement block after the check statement will be ignored, and the next loop pass will start, just as it did with the continue statement. The check statement is a little bit like a combination of the if statement and continue statement we used in the last exercise. Let's have a look at the code and see it in action. So here we have the do statement from our previous exercise. So let's edit this, and we will keep the do 15 times. I'll just take the breakpoint off for now so it looks a bit better. We will increment the variable a, and then we will say, instead of the if, check sy index not equal to 2. And then we will get rid of these 2. So this will check to see if the sy index system variable does not equal the value of 2. And if that statement is true, it will carry on processing the code. If the statement is untrue, the right statement will not be executed, because processing will jump straight to the top of the do statement again. Let's debug the code and see how it works. We will have a look at sy index and a, and then I'll press F5 to step through. So sy index has a value of 1 at the moment, so that's fine. We know that 1 is not the same as 2, so it will write out our statement to the screen. Our next run through, now this time sy index is equal to 2. So our statement is not correct. So it should terminate the processing of this loop and go straight back to the top. Let's have a look. I'll press F5. There we go. It jumps straight to the top of the loop. Now it's equal to 3, so it should execute the right statement. And it does, and so on. So it should execute it 15 times. I'll press F8 to zoom. And there we go. Process 15 times, but missing the second right statement. So it's very similar to using the if and continue statements in the last exercise, but we can do it with just one line of code. Now when you are looking at programs that have been created by other people, and maybe creating programs yourself further down the line, don't be surprised to see the check statement outside of loops like the do loop or the while loop. Because the check statement doesn't only terminate an individual loop run or loop pass, but it can also be used to check other processing blocks, like subroutines or events. When the check statement is executed, it all depends at what level in your program it is being executed. If our check statement was outside of this loop, then it would actually terminate our program. If it was inside another processing block, maybe the @screen selection processing block, well, it would terminate that block of code. So you can use the check statement wherever you like. Just be aware of where you're using it, because that will have a big impact on the processing of your code. Let's have a quick example here. Let's stick the check statement outside this loop and just see it in practice on how it will terminate our program. Create a few blank lines. I'm going to stick that asterisk there, so we've always got a few blank lines for us. And all I'm going to do is write a brand new check statement here. So check, and we'll check the value of A. So we're going to check the value of A is equal to 1. Now of course, we can see here we're setting the value of A to 0. So this is never going to be true, which means it's not going to process the rest of our code. Let's activate it. We'll stick a breakpoint. Well, let's get rid of this one first. Stick a breakpoint here. So we'll set the value of A to 0. And now we'll do the check statement. And the program ends. So as soon as it hit the check statement and the value was not true, the check statement caused processing of our code to step out of the current block, which in this case was the program itself. We can also use the exit statement to terminate loops. The exit statement allows us to terminate a loop immediately without any condition being checked. Now you may think, well, isn't this the same as the continue statement? Well, it sounds as though it's the same, but there is a difference. Where the continue statement stops processing the current loop and jumps back to the top of the loop to carry on, the exit statement terminates the whole loop itself. So once the processor meets the exit statement, the whole loop will finish and the program will continue to process a statement immediately following the closing statement of your loop, such as the end do or the end while. Now keep in mind, because we can exit loops using this exit statement, it will only exit the current loop. So if we have nested loops and we hit our exit statement within, say, the second level of the nested loop, only that level loop will terminate and we'll go back to the higher level loop. Now the exit statement can also be used outside of loops, just like the check statement. But you've got to be aware that if you use the exit statement outside of a loop, it will terminate whatever type of code structure you are currently in. So for example, if you use the exit statement within a subroutine, it will terminate the subroutine and processing will return back to the calling program. If you use the exit statement in your calling program and it's not in a loop or a different event structure, then it will actually terminate your whole program. So just be aware of where you use it, what context. So let's have a look at the code and see how we can use the exit statement in the examples we've been looking at so far. So with our example do loop, let's change this code. So instead of having this check statement, let's change this back to an if statement like we've had it before. And let's do this. If the SY index is equal to 3, let's exit. And what I'm going to do here is just create another couple of write statements just to act as fillers. So that once our loop exits, we still have some code that will execute afterwards. So by looking at the code, it should be pretty straightforward how it works. We step inside our loop. When we meet the third iteration of the loop, this if command will return true and therefore execute our exit statement. Now note there's nothing else you need to add to the exit statement. That's all there is to it. So it's pretty simple. Once the exit statement is met, then processing will drop straight out of the loop and jump to the two write statements we have at the end of the program. So let's do a syntax check, activate it. Oh, just one thing. We have a row check statement just here. Let's take that guy out. I'm sick of seeing this little fella, and you know, while we're at it, let's comment out this. Okay, let's activate again. That looks better. Let's get rid of this breakpoint, and we'll set it up here on the initialization of A. And now we can test the program. So I will just press F5 to step through. And we are in the first iteration. And the second. And now SY index equals 3. So we should execute the exit statement. Which we do. It doesn't continue doing the loop. It jumps to the top and then straight back out to the end do. And continues with our write filler statements. So we'll step out and then let's do one more change. Just to show this in action. If we have it outside of a loop, we should never get to execute any of this code. As soon as the exit statement is hit within our program should terminate. Let's test it. There's our breakpoint. F5, F5 again, and there we go. The program exited without writing anything out to the screen.